Student over there.
All right. Today we're talking about, we're going to start with the cofunction identities.
Oh man, I spelled identities wrong.
Cofunction identities are located smack dab in the middle of your identity sheet. We have two of them. Let's just copy them down so we can discuss them. The first one is that the cosine of pi over 2 minus theta, the cosine of pi over 2 minus theta is equivalent to the sine of theta. You can also swap these trig functions, and that would also be an identity. The sine of pi over 2 minus theta is equal to the cosine of theta.
How? I don't understand how.
We'll talk about it. There are a couple different ways that I can explain this to you. How many degrees is pi over 2? 90. 90, right? So what this is saying is if you take the sine of an angle, that would be the same as taking the cosine of 90 minus that angle. Okay? Let's think of an example. What is the sine of 30 degrees?
Pi over 6.
Let's write it down. What's the sine of 30 degrees?
Pi over 6.
It's the sine.
Oh yeah.
It's 1/2. Okay, what is 90 minus 30? 60. What's the cosine of 60 degrees? Oh, it's 1/2. Now, why does this work? Let's think about our right triangle. Here, for example, let me give you a 3, 4, 5 right triangle.
Here we go with this.
And let's say this angle down here at the bottom is theta. What would the sine of theta equal in this triangle? What would the sine of theta, if you're thinking SOHCAHTOA, what would the sine of that angle be? Why is it 4 over 5, student? Opposite over adjacent, right? Sine is opposite, not adjacent. Hypotenuse. It's Halloween and we can't think straight. Sine is opposite over hypotenuse, I think is what we meant. So 4 over 5. Okay. Now, in a different color, this angle right here, how many degrees is that angle?
Which one?
This angle right here. No, how many degrees is that angle?
30.
Whatever that.
Yep. Whatever what?
90.
No, say it. This, let's say that this angle is theta degrees. How many degrees is this angle?
Theta
90
degrees.
minus whatever that.
Yes, 90 minus theta. How did you get that, student? How did you get that?
How did you get it?
How did you know that this angle was 90 minus this angle?
So all adds up to 180.
Okay, so couple things. Triangle sum theorem. All of the angles in a triangle add up to 180. So in a right triangle, stay quiet, I'm recording. In a right triangle, you have a 90-degree angle, which means that these two acute angles must always add up to 90. What is the geometric term for two angles that add up to 90? If you need a hint, it starts with CO. Complementary. Let's write that down. Complementary angles. Complementary angles are two angles that add up to 90. Do you guys also remember two angles that add up to 180? Supplementary. Very good. Okay. So, these two angles are complementary. Now, let's talk about this one up here, and let's call it 90 minus theta. Can you tell me what is the cosine of that angle up here? You should be thinking SOHCAHTOA. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. We're finding the cosine of this angle up here. So adjacent would be 4 over 5. And what you will notice is that these are the same. Why? Because math.
Because
what you did there with the triangle.
Right, but sine is opposite over hypotenuse and cosine is adjacent over hypotenuse.
The opposite of the theta.
When you switch angles, the opposite and adjacent switch roles, right? So when you're looking at this angle, this is opposite and this is adjacent, but when you're looking at this angle, now that's opposite and that's adjacent, and they switch. So the cosine of one will be the sine of its complement, which is why these are called cofunctions. Sine and cosine are cofunctions because the value of one is going to equal the value of the complement of the other. So these two angles are complementary, right? 90 minus theta and theta are complementary. They add up to 90. Same thing here. So the cosine of one is going to be the sine of its complement. And that's what cofunction stands for. It's really complementary functions. Okay. Yeah, and I basically showed you that example. So we're not going to work a whole lot of problems with these, but you do need to have those identities memorized. Here's another way of thinking about it, because I know everybody loves the trig graphs.
You lied.
What kind of transformation did I just do to this sine function?
A shift.
A shift. So look, if I start with the sine curve and I shift it over pi over 2, what is it now? Now it's a cosine function. So you can either think about these identities in terms of the right triangle and SOHCAHTOA. You can think about it in terms of shifting one function. It's all the same. It's all related. Math is great. Connected forever. All right, we're going to move on to our sum and difference identities. Here we go. Sum and difference. Okay, student, this is being recorded. Thank you. Sum and difference identities. All right. We actually have 6 sum and difference identities. Today we're going to focus just on cosine and sine. We're going to save tangent for tomorrow after we've kind of grasped what these identities are used for and how we solve problems with them. But what I want you to notice is that we are going to learn how to find the cosine of the sum of two angles or the cosine of the difference of two angles. Same thing for sine. So we have both cosine and sine, sum and difference. Okay, now we're going to write them out. I'm going to help you learn how to memorize them, and then we'll work some problems. So the first one is the cosine of A plus B. Coming back up here to the top where I drew this picture, if A is an angle and B is an angle, and you add them together, you get a bigger angle called A plus B. So you can take sines and cosines of the small angles or of the big angle, and that's what these identities kind of help us with. Okay, so we're going to expand this out. Most common mistake is people just think I can distribute the cosine. Oh, well, that must be equal to the cosine of A plus the cosine of B. That is not true at all. This is not a number that can just be distributed. It's a function. And so it doesn't work like that. What this is equivalent to is the cosine of angle A times the cosine of angle B minus the sine of angle A times the sine of angle B. Please be very careful when you copy this down. So the cosine of A plus B equals cos A cos B minus sine A sine B. We're going to go ahead and write the difference one up there. The cosine of angle A minus angle B is equivalent to cosine A cosine B plus sine A sine B. Wow, those look very similar to each other. What's the only difference that you notice? The sign in the middle changes. How is this sign related to this sign? They're opposite. So for cosine, that plus or that minus is going to change. It's going to switch from plus to minus or minus to plus. So if you have a highlighter, you might want to emphasize that in your notes, okay? I also want to go ahead and put the formulas for sine up here. So the sine of A plus B is equal to the sine of A. Do you think it would just be sine A sine B minus cosine A cosine B? No, because if I did sine A sine B, then I'd just be using this identity up here. So actually for sine, we're going to switch it up. It's going to be the sine of A times the cosine of B plus the cosine of A times the sine of B. Again, copy that down carefully. And then the sine difference formula, again, looks very similar. Sine A, cosine B. This time it's a minus cosine A, sine B. So have all four of those copied down. Let's talk about how we can memorize these. All right, now between these two, what's the only difference?
The plus and minus.
Again, the plus and the minus is the only thing that changes when you go from a sum to a difference formula. But how is this related to this? For sine, it's the same. For sine, it's the same. And for cosine, it changes. So let's write that down to help us remember. On our cosine identities, the SIGN, because it's very unfortunate that sine and sine are homophones, but they're very different words. So for the cosine formulas, the sign changes from a plus to a minus or a minus to a plus. And for sine, the SIGN sign is the same. Plus and plus, minus and minus. So those start with a C and an S to help you remember cosine and sine. All right, now, what is identical about all four of those? The A and the B. So no matter what, all the A's are here and here. And no matter what, all the B's are here and all the B's are here. You don't have to highlight that, but you can if you want to. I highlighted in a different color to emphasize that all the A's are here and all the B's are here. So that's the same no matter which one you do. That's one thing to memorize. A, B, A, B. It's an A, B pattern. It's one of the first patterns you learn when you're in pre-K. Flower tree, flower tree, flower tree. They're like, what comes next? And you're like, flower tree? And you're like, yeah, that's an A-B pattern. Very good. Okay, now for the two cosine formulas, which function do we start with? Cosine. Okay, that's easy. For sine, which function do we start with? Sine. Okay, so that kind of gives it away whether you're using a cosine sum and difference or a sine sum and difference. And then this plus or minus in the middle will help you figure out whether it's a sum or a difference. Is the sign the same, or does the sign change? Okay. Now, as far as these are kind of weird. For the cosine one, you have cos, sine, sine. Both of the cosines go for y'all. Cosine is really conceited, and so it puts itself first twice, and then sine comes later. So cosine is really conceited, and we do cos. Sine, less conceited, but notice that we have a sine, cos, sine sandwich right here where the signs are on the outside just like a sandwich, and you know that also starts with S. So stupid ways of remembering things, but you do need to memorize those so you can think about your sandwich, your conceited, your change, and your same, and your A-B pattern to help you memorize those. Okay. I do want you to make a note here at the bottom that A and B are angles. And even though we just used radians in the last unit, today we're going to mix and match. We're going to use some radians and use some degrees. It's been a minute since we've been doing degrees, but we can do some of that today. So A is an angle, B is an angle, but A plus B and A minus B are also angles. A plus B and A minus B are also angles. They might be bigger, they might be smaller. Depends on if you're adding or subtracting. All right, the directions for problem 1 is to find the exact value. Find the exact value. So we're going to do this for the next, for our first 5 examples. Find the exact value. Number 1, we're going to find the exact value of the cosine of 15 degrees. How do we do that? 15 degrees. Is 15 degrees on the unit circle? If you still don't have your unit circle memorized, or you memorized it at one point in your life and then you forgot it, you may want to also get out your unit circle to look at it for a little quick reference today. Unit circle. If you don't have it memorized like the back of your hand, then get it out. All right. 15 degrees is not one of our special angles, is it? It's not. We've got 0, 30, 45, 60, 9, okay, etc., etc. So how are we going to work this? Well, is it possible to write 15 as either a sum or a difference of 2 angles that are already on the unit circle?
Yes.
Which 2 angles? Okay, you could do, so I heard someone say 45 minus 30, that is 15, so that would work. I heard someone else say 60 minus 45, that is also 15. Do you see anything else that would work? You could do 135 minus 120. You could do 150 minus 130. Hey, you can get real crazy and do 315 minus 300 if you really want to. Most of the time, I'm going to say y'all are probably going to stick to your comfort zone, which is the first quadrant, and we're most comfortable in the first quadrant where everything's just happy and positive. Get it? Everything's positive there. Let's look at this positive land up here. So if you can find 2 angles here, that's probably going to be the easiest thing for you. The thing about these problems is there's no one right way to do it, and so the way that you do it and the way that your neighbor does it might be a little bit different. That's fine as long as all of your numbers are mathematically correct. Okay, so essentially what we're doing is we're rewriting this as a sum or a difference, in this case the difference of 2 angles that are on the unit circle. So 45 and 30 are both on the unit circle, and the difference of 45 minus 30 is 15. Does everyone agree that these 2 things are equivalent? Mm-hmm. Yes, okay. Now that we pulled that 15 apart and written that as a difference, we know how to find the cosine of the difference of 2 angles. Which angle is my A? That's the 45 is the A. And which angle is the B? The 30 is the B. Right? So we're thinking, okay, the cosine of A minus B is equal to cos A, cos B, change to a plus, sine A, sine B. But instead of A's and B's, we're going to plug in these 2 angles. So everywhere you see an A, you're plugging in a 45, and everywhere you see a B, you're plugging in a 30. So let's try that. So this is going to equal cosine of 45 times cosine of 30. Please put your degree symbols on all of those degrees. Plus, because that's a minus and it changes to a plus, plus the sine of 45 degrees times the sine of 30 degrees. Because we picked 2 angles on the unit circle, I know the sine and the cosine of both of those angles. That will allow me to calculate this cosine of 15 and get an exact value without using a calculator. Okay? So let's evaluate. What is the cosine of 45 degrees? It's the square root of 2 over 2. And what is the cosine of 30? It's the square root of 3 over 2. And what's the sine of 45? Square root of 2 over 2, and the sine of 30 is 1/2. Now mathematically, using our order of operations, what would we have to do next? We're going to multiply first. So we're going to multiply these cosines together and multiply these sines together. And then at the very end, we would add those two things together. So you have these four things. We got these four things. We're going to multiply these together and add them all together, like that. Okay? Equals. This is like the hardest part for some people. What's the square root of 2 times the square root of 3? I know you don't know. Is it the square root of 6? Is it the square root of 5? Is it square root of 2 times square root of 3? Is it... See, it's not even pre-cal that's hard. It's just multiplying that's hard. It's the square root of 6. This is one of your exponent laws. If two functions are being raised to the same exponent, you can multiply the bases together. This is 2 to the 1/2, and this is 3 to the 1/2. And because they have the same power, you can multiply those bases together, and you get 6 to the 1/2. That's an exponent law that you definitely learned in Algebra 2 last year. Yeah, okay. Over what?
4.
We're multiplying. 2 times 2 is 4. We're smart. Okay. Square root of 2 plus 1 times, square root of 2 times 1 is the square root of 2. 2 times 2 is 4. All right, what do I need in order to add or subtract two fractions? You already have one. You're welcome. So, next hardest question is, what is the square root of 6 plus the square root of 2? It is not the square root of 8.
Square root of 6 plus 3.
Yes, as you learned in Algebra 2, those are not like terms. You cannot combine them together unless they have the same radicand. So we just kind of push them closer together and then combine that into one fraction. That's your answer. Ew. It's exact. It's beautiful.
It's disgusting.
You don't believe me?
Nah.
Somebody say, I don't believe you.
I don't believe you.
Okay, thank you. Let's put my calculator into degree mode. I'm going to show you, what did we find? We found the cosine of 15 degrees, which is it's an ugly decimal. But let's just see here. What is that? Get out of here. The square root of 6 plus the square root of 2. Watch this be wrong. I'm just going to laugh so hard. Okay, good. They're the same. They are the same, but that's an ugly answer, and that's a beautiful, exact answer. All right, let's try for number 2. I'm going to switch to sine, and I'm going to also switch to radians because you got to be able to do these problems in radians, and you're not going to like it as much, but here we are.
Is that 12?
5 pi over 12.
Why?
Why? Because I'm your pre-calculus teacher.
I think you're on the wrong percent.
All right, so 5 pi over 12. Again, the goal here is to find two angles on the unit circle, of which we know the sines and cosines. Here's my unit circle. That add or subtract to give you 5 pi over 12. Now that's a little bit awkward because we've got all these different denominators, 6, 4, 3, 2, 3, 4, 6.
Could it be like 5 pi over 6 plus pi over 6? Or do you not?
5 pi over 6 plus what? Pi over 6? That gives me pi. And I need 5 pi over 12.
How do you even add these?
How do you add fractions?
You need the common denominator.
What is the common denominator for all of those fractions? It's 12. 6, 4, 3, and 2 is 12. How convenient. This is also over 12. It's like I knew what it was going to be. Okay, so off to the side or at the bottom or at the top, what I want you to do is let's just write all of these special angles in terms of twelfths, and then it'll be a little bit easier for you to pick out two that add up to 5 pi over 12 or subtract to 5 pi over 12. Pi over 6 is how many pi's over 12?
2.
2. What about pi over 4?
3.
That's 3 pi over 12. Oh, look, we already found it. 2 plus 3 is 5. Let's just keep going because we're going to need all of them at some point. Pi over 3. That's 4 pi's over 12. What about pi over 2?
6.
That's 6 pi over 12. So you can kind of do like any combo here. Let's keep going. 2 pi over 3.
Okay, so
3 times 4 is 12. 2 times 4 is 8. Very good. Whatever you multiply the bottom by, multiply the top by the same thing. What comes next? 3 pi over 4 is 9 pi over 12. Okay, and you could keep going, but we've definitely done enough where you could pick out 2. So, what do you want to do?
replace 2, please.
Now, if I didn't tell you anything and I just said find the sine, you could either do a sum or a difference. If you chose to do a sum, maybe you add 2 pi over 12 plus 3 pi over 12, right? What if I told you had to do a difference?
8 minus 3 pi.
8 pi over 12 minus 3 pi over 12? Yeah, let's do that one. Why not? Let's do it.
Get out.
Let's do it. So I'm going to write this as the sine of 8 pi over 12 minus 3 pi over 12. If someone else in here would kindly do it with 2 pi plus 3 pi and see if you get the same thing as us, I would like to use your example to demonstrate to the class that there are multiple ways to solve these problems. Anybody want to try the sum? Okay, yeah, that's fine. If more than one of you want to try doing 2 pi over 12 plus 3 pi over 12. Meanwhile, we're going to try 8 pi over 12 minus 3 pi over 12. Okay, so after you pick out your 2 angles on the unit circle, you may want to go back and reduce them so that you recognize them. 8 pi over 12 was 2 pi over 3.
Oh.
I'm just re-reducing them, putting them back. 3 pi over 12 is pi over 4. Okay, so now I am using the sine difference formula for this. So the sine difference formula looks like this one. Sine A cosine B minus cosine A sine B. I'm letting 2 pi over 3 be my A and pi over 4 is my B. Okay.
Why did you do that?
What?
Why did you put it? Never mind.
All right, so it's going to be sine A, sine 2 pi over 3, cosine of B, which is pi over 4. And then is this going to be plus or minus? Sine has the same, so that's a minus. And now it's going to be cosine A, 2 pi over 3, times the sine of B, pi over 4. Does everybody understand where I'm getting these 4 things from? I'm taking those 2 angles and I'm just plugging them straight into the formula, okay? The rest of this is evaluating. You're gonna write down those 4 values. So the sine of 2 pi over 3 is square root of 3 over 2. The cosine of pi over 4, square root of 2 over 2. The cosine of 2 pi over 3 is negative 1/2, and the sine of pi over 4 is negative square root of 2 over 2. You multiply these, and then you subtract those 2 products. So that is a square root of 6 over 4. Now this one is minus a negative.
So it's plus.
So I'm going to write a plus, and then square root of 2 over 4. And then I get the square root of 6 plus the square root of 2 over 4. Hey, those answers look very similar to each other.
Here you go with this machine.
Why did I get the same answer for the cosine of 15 and the sine of 5 pi over 12?
Because we're both not on the unit circle. But mathematically speaking.
Does anybody know how many radians 15 degrees is?
I know it's between 0 and
How do you convert from degrees to radians, everyone?
pi divided by 180 or 180 to pi, yeah.
Oh, so 15 degrees is actually just
Pi over 12.
1 pi over 12, and look at this, 5 pi over 12. Hey guys, what's 1 pi over 12 plus 5 pi over 12? What is 6 pi over 12? Oh, it's like that's a cofunction identity.
Oh my Lanta.
Yeah, so we got the same answer because I took the cosine of one angle and the sine of its complement, and of course I would get the same answer. Did anybody do it the other way?
I did.
Bring it up here if you did it the other way. Student?
Oh my.
I'm still recording.
Oh my. Student, go sit down.
You shush, student.
Oh, almost fell.
Okay, tell me. Hold on, scooch over, scooch.
My
Okay.
slide's bad.
All right, so this student did it with a sine sum identity and wrote 5 pi as 2 pi plus 3 pi. That's pi over 6. That's pi over 4. So it's sine, cos, sine. And then we got yes, no.
Oh, I'm stupid. Sorry.
No, you're not. What is this?
You
What
just
should this equal?
miscalculated.
What should this one equal?
Oh.
The square root of 3 over 2. And so
I'm
this
slow.
is a
You're
6.
saying the same.
You
You're not
did
slow.
get the
Yes, I am.
same answer, and you did it a completely different way.
Wait a minute, huh?
Thank you. Bravo,
You did not get
student.
the same answer.
Huh? Oh, no, I'm joking.
Number 3.
Time to go sit down.
Come on, we gotta hurry.
I got my stuff back, stupid.
Go sit. All right. I would like you to try the sine of 17 pi over 12. 17 pi over 12.
I'm gonna chew my foot off.
So find two angles on the unit circle that either add or subtract to give you 17 pi over 12. I will warn you that 17 is a pretty big number, so it's probably going to be a sum. But let's look back at our pi's over 12. Do you see two that add up to 17?
8 and 9.
I probably use 8 and 9. Now, does it matter if I do 8 plus 9 or 9 plus 8? No, it doesn't. Now, your work will look a little bit different depending on your order, but when you add, the order doesn't matter. That's the commutative property. So I mean, when I'm doing it, I generally just put the smaller one first, but you can do either way. So 8 pi over 12 plus 9 pi over 12 makes 17. Let's reduce those so we recognize them on the unit circle. 8 pi over 12 is 3 pi over 4. No. 2 pi over 3. Ooh. Sorry. That's ick. Let me try it again. 2 pi over 3. And 9 pi over 12 is that one 3 pi over 4? Okay, 3 pi over 4. 3 pi over 4. Okay, now, is that sine, cosine, sum, or difference?
Sum. Oh, sine.
So it's sine. So we're going to start with the sine. This is my A. This is B. Okay, so it's going to be sine of 2 pi over 3. Cosine of 3 pi over 4. Sine is the same. Sine plus cosine of 2 pi over 3. Sine of 3 pi over 4. Again, it always goes A, B, A, B every time, no matter what. Sine is a sandwich. We got the same plus in the middle. Okay, let's evaluate that. The sine of 2 pi over 3 is square root of 3 over 2. Cosine of 3 pi over 4. Negative square root of 2 over 2. Plus the cosine of 2 pi over 3 is a negative 1/2. And the sine of 3 pi over 4 is a positive square root of 2 over 2. Giving us a lovely negative square root of 6 over 4 plus a negative square root of 2 over 4. We already have the common denominator, so we're going to just mush those into one fraction. And we get negative 6 minus square root of 2 all over 4. And again, the order doesn't matter here because those are both negative. So if you wrote negative square root of 2 minus square root of 6, that is also correct. Why are we using 6s and 2s? Well, you notice that the sines and cosines of all the angles are either 1/2 or square root of 3 over 2 or square root of 2 over 2. So you will see those very commonly in all of these problems that we're doing, okay? All right, the last thing that we're going to do.
Oh, no.
What is the sine of 80 degrees times the cosine of 20 degrees minus the cosine of 80 degrees times the sine of 20 degrees?
Oh, that's the.
Oh my. Let me just read this.
Sine 80 cosine 20 minus cosine 80 sine 20. Now, is
this
20
is
on the
sine.
unit circle?
No.
Nay. Is 80 on the unit circle?
No.
Nar. So how am I supposed to do this? Well, what some of you have recognized is like, what does that look like?
That equals 100.
It looks like one of these sum and difference identities, but which one, first of all, is it going to be a sine or a cosine one? How can you tell? It starts with a sine, so it's going to be a sine identity. Okay, equals sine. Then is it going to be sum or difference? How do you know? There's a minus sign, so it's going to be equal to the sine of something minus something. Now, what is that first angle? 80, because here's your A's, right? So that's 80 is my A, minus 20 is my B. So what I'm trying to tell you is that you're recognizing that pattern as one of the sum and difference identities, and we're working backward and we're condensing it back into the left side of the formula, because now what's 80 minus 20? It's 60, and that is on the unit circle, and we know the sine of that angle is
What am I doing?
the square root of 3 over 2. Wow.
Oh my.
So it's like we're squishing it back together and then getting one angle that we actually know on the unit circle, okay? Try this one on for size. The cosine of pi over 12 times the cosine of pi over 4 minus the sine of pi over 12 sine of pi over 4. Cosine pi over 12, cosine pi over 4, minus sine pi over 12, sine pi over 4. You're like, that looks like a sum or difference identity. Is it sine or cosine? Is it sum or difference? It's sum, because it changes, right? So this is equivalent to the cosine of some angle plus some angle. What are the two angles? Well, it's your angle A is your pi over 12 and your angle B is your pi over 4. Now, we do need to get a common denominator to add those. So pi over 12 plus 3 pi over 12. My common denominator is the 12s. Put those together. That equals 1 plus 3 is 4. 4 pi over 12. Now reduce it back. 4 pi over 12 is equivalent to pi over 3, and we know that the cosine of pi over 3 is equal to 1/2. Beautiful. Don't worry, the problems will continue to get harder.
That's great. Awesome.
But I'm going to stop there because I do actually love you, even though you feel like I hate you. But I'm just teaching you pre-cal. I'm just literally doing what I get paid for and, trying to make it as painless as possible. And tomorrow we'll add tangents.